Hello everybody, and welcome back to our video on Introduction to Integration. Now we're going to talk about section 18E. We're going to discuss some rules for integration. So these rules are all listed on page 457 and 458 of your book. Okay, so just notice that if we have one rule for integration already. If we want to end up with a constant in front of x, if we want to end up with the integral of k, so if we want to end up with a derivative that is k, then we need to have k times x plus c as my original function. Here, if I wanted to end up with a derivative that is x to a power, then I need to do x to the n plus 1 over n plus 1 plus c. That's the rule we saw in the previous video. If I want to end up with a derivative that is e to the x, I need to start with e to the x plus c. If I want to end up with a function that looks like this, 1 over x, I need to start with ln x plus c, because the derivative of ln x is 1 over x. If I want to end up with cosine x as my derivative, I need to start with positive sine x plus c, because the derivative of sine x is positive cosine x. And if I want to end up with the derivative of sine x, I need to start with negative cosine x plus c, because the derivative of cosine x is negative sine x, and I multiply by negative 1 to get a positive sine x. Okay, so to go from this to here, I need to differentiate. To go from this function back to the original function, I need to anti-differentiate. Sorry for the lag on my computer. It should be coming up. Okay, so again, we mentioned this rule before, but if we have a constant times a function, we didn't mention this rule. If I have a constant times a function in my derivative, I can take that, I can basically factor out that constant and take the integral of just the function. And likewise, this is like the sum rule or the difference rule in differentiation. If I'm taking the integral of two functions, I can take the integral of each function separately and add or subtract them. Oops, sorry about that. So we'll look through a few of these examples. If I want to end up with x to the 6 as my derivative, I need to start with x to the 7 times 1 over 7 plus c. If I wanted to end up with just 4, I need to start with 4 times my variable plus c, and in this case, because they said dt, I know my variable must be t. If I want to end up with 3x to the 5, I can start by factoring that 3 out of my integral. Then I have x to the 5, and I know the integral of x to the 5 is x to the 6 times 1 over 6 plus c, and I can multiply those constants together. Notice I don't have to multiply the 3 times the c, because c is representing a constant. 3c and c in this case mean the same thing. If I'm starting with something more complicated like this, I can start by breaking it down into 3 separate integrals. Then I can factor out those constants from my integrals. Then it's easier for me to apply the rules that I know. For u to the 4, I can do u to the 5 times 1/5 to get my original function. That gives me an integral of u to the 4. For u squared, I can do, the integral would be u cubed times 1/3. And for 2, the integral would be 2 times u, because I wanted to, if I took the derivative of u, I would just get 2. Okay, and then I can simplify those factors. And finally, for e, here I have two functions. I'm going to split them up using that sum rule. I'm going to take the integral of x, which is x squared times 1/2, and I'm going to rewrite this as x to the 1/3, and I'm going to do x to the n plus 1, so that's why I get 4/3, times 1 over n plus 1, so 1 over 4/3. Remember that 1 over 4/3 is the same as 3/4, times x to the 4/3 plus c, and don't forget we also have this 1/2 x squared part. Thank you.